Okay, our question was, what is the effect of changing the angle of the drop and then the number of periods in 30 seconds? And we said increasing the drop of the angle will increase the number of periods, decreasing the angle of the drop will decrease the number of periods, because, you know, that makes sense. It doesn't.
So we found out with the bar graph we showed that the average is 19, so no matter the angle of drop, all the number of periods in 30 seconds stayed the same.
And we got 19 like every time, like in 30 and 60, and then a little bit off in 90. But so we graphed the averages, and they're all 19.
So our conclusion proved our hypothesis wrong, as changing the angle of the drop doesn't change the number of periods in 30 seconds.
So kids are going to be like, oh my gosh, my answer was wrong, my hypothesis was wrong. What do you want to tell your students if their hypothesis is wrong?
It's okay, like that's why you did the experiment, just to figure out like if what you were thinking was right or wrong.
Yeah, so you learned something, right? Good. So you all want to share your questions. And again, I gave questions to each person because if you have in elementary age students and they all finish at different times and they have absolutely nothing to do, that's when chaos is going to reign in your classroom. So you always want to have something in your back pocket to pull out to keep their minds occupied.
My question was, what other questions could you ask your students to focus their thinking? We talked about how we could have them talk about the conclusion and relate it to their hypothesis and have them try to figure out why that it didn't change.
My question was, do you think that the period of the pendulum depends on how far the bob is released from the point at which it is hanging straight down? And obviously, no, it didn't matter because our data showed that the average stayed the matter, the angle of the drop.
My question was, why should you only vary one variable in an experiment? And kind of like what we talked about, if you change too much, then you're not really seeing what the experiment can show you.
And mine was, how could you assess student understanding of the concepts presented in this activity? And we talked about like you could have them group up or just do an individual activity where they did this and you kind of had a checklist of things that you wanted them to include. And just we talked about how in elementary school the scientific method was something that was really enforced. So just making sure they understood that concept of how to produce an experiment.
Okay, nice job. All right. You can just leave it there, that'll be fine. Next group.
Okay, so for ours we had what is the effect of changing the mass of the bulb on the number of periods in 30 seconds. And we said that if you increase the mass of the bulb, it will increase the number of periods in 30 seconds. And so of course if you decrease it, it will decrease the amount of periods in 30 seconds.
And then for our graph, or for our data, we had the mass for the small, medium, large, and the small, it weighed 0.2 grams, and or is 22 swings or periods back and forth each trial. And then medium is 0.3 grams, and is 21.5 each trial, and the large one was 0.7, so it was like about a bigger jump, weighed a little more, and it was 21.5 for all three trials as well.
So in conclusion, the mass did not affect the number of periods in 30 seconds because there was only a difference of 0.5 in the number of periods.
So we had the idea maybe that, or we found out the mass does not affect, of the blob does not affect how many periods it will swing in 30 seconds.
Which is counterintuitive to what you would, I mean, obviously different than your hypothesis, but
We thought that, you would think that a 0.7 grams would swing more than 0.2 or 3, but it didn't.
okay. And your questions?
My question was, how could you provide more guidance to elementary students as they conduct this experiment? This is not my question. My question. I was wondering what. I said that you can have like already like pre-made charts for them to fill out, or like the graphs and like have them fill it in, and you can already like
Good. So you could just make it a little bit more constructed. Is that it on the right-hand side? There looks like there's a little white piece of paper there. I don't know if that, no, that's not it. Sorry. That's okay.
What was yours?
I found it.
I was looking for my questions where they go.
Sorry. Okay, my question was, what science concepts are addressed by the pendulum activity? And I said variables, constants, hypothesis, and mass.
Good, good. All right. And even the scientific method, right?
Yeah.
Good.
Okay, so my question was, did you predict that the mass of the ball would affect the period of the pendulum? And we said yes, it would increase.
And then I had what prior knowledge my elementary students have about pendulums. And I did what you kind of introduced us with, of the pictures of like the swings, the grandfather clock, and amusement rides of the swings. They probably have most of them have been on one of those or seen it, but they might not realize that's what it is.
Okay. Nice job. All right, so the last two groups, you all have the same question. So let's bring your all's charts up. Have you all spoken with each other to see if your conclusions are the same?
We have not.
So let's see.
Okay, so our question was, what is the effect of changing the length of the string on the number of periods in 30 seconds? And they have this question. Do y'all want to share your hypothesis?
Our hypothesis was the shorter the string, the more periods will occur in 30 seconds.
And we have the same hypothesis.
Okay.
And for our data, we actually did different measurements because we did 5 inches, 10 inches, and 15 inches, and their group did 6 inches, 12 inches, and 18 inches.
I noticed that while I was thinking up here.
It's interesting. Okay.
But for our 5 inches, the average was 37.6 repeating periods, and for 10 inches, it was 26 and 6/10 repeating periods. And
Good
15
use of math.
inches, it was 22.6 repeating periods, and we graphed it with a bar graph.
Okay.
Okay, so our average for 6 inches was 35 2/3, and 12 inches was 25, and 18 was 21. They just basically stay the same.
We concluded that the hypothesis tested was correct. The shorter the string, the more periods occur in 30 seconds.
Yeah.
We had the same.
Same conclusion.
Yeah.
So when we started this, you all thought maybe the angle of the drop would matter. Maybe the mass of the bob would matter. Maybe the length of the string would matter. But only the length of the string matters. And if you think back, remember we started talking about a grandfather clock. If there is one, do you remember like every day they pull the string?
Yeah.
That has to do with that. I don't know, I'm not a grandfather clock expert, but that's what it has to do with that. So the length of the string is the only thing that changes the amount of swing in a pendulum. Great. So now, your all's questions.
My question was, where do pendulums use, or where are they used in real life? We've kind of already talked about it, but grandfather clocks, I've also seen like metronomes.
Oh.
At a pendulum, like swings, amusement park rides, all those things.
So that's a great point. A metronome that keeps time for music. And I guess the thing that they do is they pull it out or push it back in if they want to speed it up. That kind of goes with that, doesn't it? Good. Good connection.
Mine was, what did you observe when just the length of the string was changed? It's kind of our conclusion. Basically, it swings more the shorter the string.
Mine was what other variables might have been used. I guess like you kind of talked about how if we didn't tape the string on the pencil, then it kind of can affect it more. So I guess that's one thing. We've noticed, or we've tested that there are two variables
Rebecca's question, I think.
Sorry.
No, you're fine. No, I'm just, yeah, okay, good. No, go ahead.
My question was, what is the difference between mass and weight? And we discussed that on Tuesday, and that weight. Whoa, I got myself confused. Weight can.
It's okay.
Yeah, I'm so confused right now.
It's okay.
I don't. Yeah, weight, like there's gravity. If it makes the weight, if you go like the space, your weight can change, but the mass stays the same.
Yes.
That's what I'm trying to think of.
Good job, you got it.
My question was, how is this activity an example of constructivism? So like using their, the students, like using their prior knowledge of a pendulum, they can learn that the more periods will occur in 30 seconds.
And they're building their knowledge. I could just as easily have given you all a sheet of paper that said, this affects it, this doesn't affect it, and then move on to the next thing. But 2 days from now, you all wouldn't remember that. You're constructing your knowledge. Okay.
Mine was, what type of graph best represents your data and why? And for ours, we did a line graph, and I thought that would best represent just because you can see like the downward, like how longer the string is, like the less periods you can see, but also on their graph you can kind of see how as the string gets longer, you can still see that it goes down. So.
Okay. And we are so short on time, we might even be a minute past. So those 2 questions we'll hang and catch first thing on Tuesday.